Alright, today we're going to be going over the dimensional analysis using, well, not dimensional analysis, but the extreme estimation using dimensional analysis. So the problem states find the number of bricks in the Roman Colosseum. So, there's my work. Where did I put it? I did this earlier so I'd be prepared. Now I lost it. Oh, there it is. There we are. Okay, so dimensional analysis itself is very, very similar to, well, actually, it's pretty much exactly the same as what we did last year in chemistry for stoichiometry. I know it might seem like it's quite a bit different, but it really is the same thing. If you remember last year from chemistry, if we did the little ladder thing where you have units and stuff on top and bottom and they all canceled out, that's essentially the same thing as this. So let's assume, well, what would be a good estimation for the Colosseum diameter? So we'll say, well, first off, how would we find the number of bricks in a Colosseum? You have to figure out the volume of a brick, the volume that needs to be filled with bricks. So let's start off with the volume that needs to be filled with bricks. And the homework just wants us to go over its magnitude, so the nearest power of 10. So let's say the Colosseum's diameter is that's really big, is 200 meters in diameter, equals diameter. And let's say that the first 180 meters, or 90%, is just air. And then let's say its height is 30 meters. And then let's say a brick is, I think Mr. Anderson said 5 by 5 by 5 centimeters. But I did a 10 by 5 by 5 because that's, I guess, a little more realistic. But we'll go with his 5 by 5 by 5. So that means the brick's volume is 125, nope, not meters, centimeters cubed. Now if we want to find the volume of the Colosseum, it would be pi r squared times the height. So, well, actually, yeah, that's how we find the volume of the whole thing. So pi r is half of the diameter, so 100 squared times our height, 30, equals, what is that, 10,000 times 30. So we'll say 300,000 pi meters cubed. So now if we want to find the volume for bricks, we take our 180 now instead of 200, and it's pi, oh, that's a horrible pi times 90 squared times 30, which is equal to 243,000 pi meters cubed. So now, if we want to find the volume of the amount of bricks that we need, it would be the top minus the bottom. So 300,000 minus 243,000 equals 57. So that means 57,000 pi meters cubed, or should be about 170 something. Yeah, 179. 179,000. Nope, no pi anymore. Meters cubed. So that is how much space we need to fill with bricks. If each brick is, as we set up here, 125, I'll erase this stuff. So if we take, well, first off, how many cubic centimeters are in a cubic meter? So there are 100 centimeters per meter. So that means there's 100 by 100 by 100, which is, I think a million? Yeah, so there's 1,000,000 cubic centimeters per cubic meter. So that means this in cubic meters is, well, if you have 125, and then your decimal point is right there, and then divide it by 1,000,000, you move it 6 spots to the left. So it goes 1, 2, 3, 4, 5, 6. So that means it would be 0. I think there's 4. Yeah, 1. No, there's 3. 2, 3, 2, 5 meters cubed. So now, how many of that is going to fit into this? You just divide 170. So let me pull up a calculator. So 179, boom, boom, divided by 0.000125 equals. So it's 179, comma 000 divided by 0.000125 equals a really big number. 1432. 1432. Boom, 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 boom. That is 101.4 billion bricks. Or if you take the magnitude of 10, it would be around 10 to the 9th. What's a 10 to the 9th to, like, well, let's, since we're estimating pretty heavily, let's say like 5 times 10 to the 5 times 10 to the 8th, or 500 million, to 5 times 10 to the 9th. So somewhere in that range is our number of bricks, which is a pretty big range, but considering most of this is guesswork, it's, you know, fairly okay. So that's how I solve it. But solving it dimensional analysis, let's do that. So if we start off with our numbers that we had before, which is volume of this, which is 179,000 meters cubed over So we're trying to find the number of bricks that will fit in the Colosseum. It's the same problem we just did, but now we're doing it dimensional analysis. So that means 1 meter cubed needs to go down here. And there are 1 million centimeters cubed in a meter cubed. So then if we take that, how many bricks, or no, how many centimeters cubed is a brick? 125, so we take 125 centimeters cubed per 1 brick. And now you multiply by the top and divide by the bottom. So let's do that. We should get the same answer. 179,000 times a million divided by 125. Look at that. Exact same answer in probably fewer steps. You just have to do a little bit of puzzle solving to figure out what's going to go where. So I'll run by this a little slower now. We're trying to get to the amount of bricks from a volume. So we know the volume of bricks and we know the total volume. So that means we need to figure out how many bricks can fit in that volume. Well, if you want to convert from one volume to another, that's nice, because you just find out how many of that unit is in the bigger unit or the smaller unit. So in this case, we're ending with bricks, which is 125 centimeters cubed. So if we're trying to get from meters cubed to centimeters cubed, and then from centimeters cubed to brick, that's what this is going. It's going from meters cubed to centimeters cubed, and then from centimeters cubed to bricks. So hopefully that makes sense. Hopefully that helps a little bit on the homework. This first one was probably the hardest out of all of them. The rest of them are relatively easy. And again, you just need like a range of magnitudes. So for this one, it's like 10 to the 8th to 10 to the 9th. And then, yeah, that's what I did for most of them. I gave a range. But hopefully that helps. And thanks for stopping by, and happy studying.